Welcome back. In this video, we are going to discuss about the program design tool called as algorithm. So whenever we have a problem and we want to write a program to solve the problem or to find a solution for how to solve the problem, you need to approach the problem by having some sketch, some design at your hand in the form of an algorithm or in the form of a flowchart or in the form of a pseudocode. So these three normally we call it as program design tools. So in this video we are going to discuss about algorithms. So in class we have discussed about this in different scenarios in different contexts. But still we will see one example here. Algorithm, this is going to be the step by step description of how you're going to solve the problem. Description of the solution. Solution to solve the problem. Okay. So it's going to be a step-by-step description. And this algorithm, what you write has to be precise, that it should be very, very accurate. The steps has to be very, very precise. The steps should be very clear. So the clarity we give by the word unambiguous, that is there should not be any confusions. It should be very clear. Okay, and the steps should terminate. Finally, the steps, whatever we view, the solution should terminate. It should not run on an indefinite loop or something. Okay, it should terminate. So these are some of the properties we expect from the algorithms what you write. So it should be precise in solving the problem. It should be very clear. That is, it should not have any unambiguous representation of the solution, and the solution should terminate. Now with this said, now we are going to find out or write an algorithm for linear search. So as you all know, linear searches, you have been given with a list of elements. Okay, you are going to be given with a list of elements. Assume that this list is stored in an array like what you see in C. And this array has, you have to be knowing the length of the array because we need to iterate over each and every element of the array. Okay, so we need to know the length. Assume that the length of the array is n. And the search key, that is a keyword or the value what you're going to search, I will take it as k. Okay, so linear searches, given a list of elements, say I have been given with a list of elements. Okay, so this is a list of elements. Oh, so you're having totally 6 elements here in the list. And anyone can search whether this particular value is present in the list or not. Okay. So when you want to search whether a particular element is present, say for example, the search key in the current example is 7. Now if you want to find out whether 7 is present or not, linear search starts from the first element and it keeps on comparing the search key with every element in the list. So it will come to first position number 1. So here it will compare the search key, that is k here, which is equal to 7. So these two will be compared, it will be checked whether they are equal. If it is not equal, now the iteration will continue to the second element, the element at the position number 2. And now again the search key will be compared with the value in the second position. And in our case, again it is not equal. Okay. So in our case, it is again not equal. So it will move on to the next element. And now it will come to the third position, and again the search key will be compared with the third element. And if they are equal, we say the element is found. If they are not equal, we will move to the next element. And now when it comes to the fourth position, the key value is exactly equal to the element at position number 4, and we have to return the position also. So along with saying that we have found the element, we will say one more thing, that the element is found at position number 4. And we can stop the search here. We need not move and search for search or compare the other elements. We will just break and come out of the loop. Okay. So this is linear search. So linear search, always in any given list, Linear search will start searching for the presence of an element from first to last. Okay, from the first element to the last element, it keeps on searching. And if it is found, it will come out of the loop. And if it is not found, it will continue till the last element. And finally, it will say that I have searched all the elements in the list and the search element is not present. So this is the procedure. So this is a procedure for performing a linear search. And for this now we have to write an algorithm. So linear search applications, it is used in several places where you have files, and whenever you have different files and you are searching for your name. Okay, assume that your result has been published in a PDF format, and you just go and search your name, whether it is present there or your register number. You search for your register number, and these kind of searches match is done with the help of searching algorithms, and linear search is one of the algorithm which is otherwise called as sequential search also. It is also called as sequential search because it starts from the first element in the array and it continues to search till the last element of an array or list. Okay, it starts the search in the first position and it will go till the end, and it sequentially makes a search, and so this algorithm is called as sequential search. Now we'll start the algorithm. So normally the algorithm or any kind of C-event programming structure or pseudocodes, it will have different type of control structures. The first is sequential, that is instructions which execute one after the other. Okay, sequential, this is instructions which execute one after the other in some order. Okay, in a sequential order, example. And we also have decision statements, that is we check for if condition. Okay, if some statement is true, okay, decision, that is conditional constructs. We check for a condition, and if it is true, we'll pass to a branch, and if it is false, we will take another branch. Okay, and there are also type of control structure which we call it as repetition, that is whenever you want some set of statements to be repeated for a particular number of iterations, say n iterations, we will call a structure called as repetition. So this is conditional construct or decision making statement, whether a particular element is true or false, and based on its truth or false, we execute a particular statement. So in any algorithm, normally we use these kind of three structures or three different types of statements. Okay. So we will start writing the algorithm. So this algorithm is for performing linear search. So always we have to put step numbers. Okay, so first default step is always start. The second step is to get the elements in the list. Okay, so I'll say input the number of elements in the list. Input the number of elements in the list. Say I will store that in n. Okay. So this number of elements I am going to store in an, that is the total number of elements in the list is capital N. Step 3. So now from 1 to n, input the elements in the list. Input the elements in the list. And store it in some a of 1, etc. up to n. The name of the list is A, and I am storing the element from 1 to n. Now coming to step number 4. Okay. So first I have got the total number of elements in the list, and now I will read every element one by one. How many times? N times I will read the input of the list. Okay, so you keep on entering the element. And step number 4 is, now you have to give one more input. You have to input the element to be searched. element to be searched. Okay, which is the search key. This is the search key, and I will call here as K. Okay, so giving these notations is important because these notations we can use for the core logic. Okay, to compare, to make decision, or to iterate. Whenever we want to make some logic to be written as an algorithm, we can use these notations. Instead of the lengthy statements, number of elements, I can use n. Okay, instead of saying that all the array elements, I can say A. Instead of saying the search key again and again, I can use K. So I am using some notations. And now step number 5. Now I'll make some initialization. So I said that you need to return the position where the element is present. Okay, or if the element is not present, I should know that the element is not present. So for which I'm going to set a counter or a flag. Okay, so which is set position equal to -1. So this will act as a flag. After you search the entire list, even then, if the position is -1, it means that you have not found the element. Okay, and whenever you find the element, you assign the particular position where the element is present to this particular variable position. Okay, so for this, I am setting or I am initializing a variable called as position. Now step number 6. So here we are going to have the core logic. So I am going to have multiple statements here. So here I am going to define the core logic for I equal to 1 to n. That is from first element till the last element. I am going to check each and every element whether the given element is equal to the search key value. Okay. So now for every element, so now this I will again label it as 6a and this will be 6b. Okay, whatever is 6b. Step 6b. Now I make the comparison, decision. What is the decision? If A of I, so A is the array where the element is present. So A of I is equal to K. Even you can say double equal to. If A of I is equal to K, okay, I am making a checking. And if that is the case, then what you should do, okay, what I will do? I will do set position is equal to this position I. Okay, this position I where the particular element is present. Okay, position I. Now one more thing I have to do here is whenever this is equal, in this case I should stop the loop or I should break the loop and I should come out. Okay, I should break the loop and I should come out whenever it is equal because I have found the item. So and I have stored the position, corresponding position in the variable position. So I should break and I should come out because I have found it. Okay. So now the flag is to check whether the element is found or not. The only flag we have is what? Position. Position is the flag we are going to use to check whether finally you have found it or not. Okay. So we have written some sub-steps in the step number 6. So whenever you have more steps, it's better you have all the sub-steps numbered. And now the step number 7 is automatically after you complete the loop, either you run through the entire loop from 1 to n. Okay, you've completely run it and you have not found it, in which case the position will be -1. And if in any position, if the element is equal to the search key, automatically the position will be set to I. So now for the final conclusion, what you are going to do is we are going to compare. Again, I am going to make a decision. That is, if position equal to -1. Okay, if position is equal to -1, in which case I can print not found. Directly I can say the element is not found. Because this was the original value which I assigned to position and the position is not changed because it never entered into this condition. Okay, A of I is equal to K, which means the search key element is not found. Okay, so if position is equal to -1, print not found. Else, Okay, else what I have to print? Else print the element is found. Element is found at position. Whatever is the position, okay, at a particular position, and the position is given by the variable position. Step 9, we will have a stop. So this is a very simple algorithm, that is linear search. So given any example, okay, so we are having a list of items, say 7, 8, 10, 2, 1, 3 and so on. And if you want to, this is a given list, so which I am here in the algorithm representing as A of, and first itself I am asking you to enter the number of elements in the list. So it is 1, 2, 3, 4, 5, 6. So 6. Then the program will ask you to enter the elements in the list, and it will store in an array called A. And later now it will compare every element in this array, that is A of 7, 8, 10, 2, 1 and 3. It will compare every element with the search element. Sorry, the search element is not given yet. So third input you have to give is the search key. Say the search key I give is 4. Okay. In which case, now I should start comparing. So before I start comparing, I am going to set a variable which is equal to -1, which is nothing but the position. So even after you go to the end of the array, if the position is -1, it means the element is not found. If this position value is changed, then you have found the element at the particular position given by the value in position variable. So first it will compare 4 with 7, whether it is equal, no. So it will go to this second element, 4 equal to 8 will be compared, no. Again it will go to the third element, 4 is compared with the 10. Again they are not equal, so it will go to the next element, 4 is equal to 10. Again they are not equal, it will go to the next element, 4 is equal to 10. Again it is not equal, it will go to the last element and compare 4 is equal to, sorry, this is 4 is equal to 2, 4 is equal to 1. And finally it will compare the last element, whether 4 is equal to 3. Again in this case they are not equal, and so now it will come out of the loop because it has processed till the end of the array, searched till of the end of the array, and position will be equal to -1, and so you conclude that you are not able to find the particular element in the array. Thank you. On the next video, we will continue with flowchart.